have to be serious and talk and stuff. Hello, I'm Adam Whittingham, for those of you who don't know. And I'm going to talk about building big software out of small pieces. So I think I potentially scared some people off when I said I was talking about service-oriented architecture. It's not going to go well if I can't pronounce the thing I'm talking about. Microservices. But in actual fact, they're actually pretty easy and they're not scary. So yeah, most projects we start off with something really small, and you do like a minimum viable product, and it's nice, it's quick, you just get stuff done, and you're happy, and you understand the whole thing. And then people want more features, and your software grows, and it gets bigger and bigger and bigger, and we add more stuff to it. It starts to get harder to move, your tests start to run more slowly, it starts to have more concepts in it, so if somebody joins the team, suddenly they've got to understand more and more things before they can actually start work on it. This is a problem that plagues all software, so we've got three choices really. One is to just stop and just say, actually it's got to the point where it's getting a bit messy, I'm not doing any more on this project. There are certain people who will just change careers at that point, or change jobs at that point. Very few projects are happy with you just downing tools and saying, I've met an arbitrary level of code, and therefore I can't continue. So that's not really an option. The problem is that one of the only other two alternatives we have to just stopping point blank is to keep getting bigger. And you go from something that was nice and small and easy to throw around and move about to something that was big, to something that's bloody impossible to reason about in one go in any detail. Like, you can only think of it in the abstract as the moon. You can't think of all these little bits and nooks and crannies anymore. And this leads to trouble. Like, it makes it harder for us to test, it makes us harder to mess around with our code, and it takes a lot of the fun out of it. So the other option is that we try and keep things small, and that's where microservices and SOA come in. I'm going to say SOA so I don't have to keep saying orientated. Where we take all of those little pebbles that we started with and all these little fun projects, and we just glue loads of them together until we've got an awesome castle. So each pebble just does one part of the overall task, but together they're something much more than the sum of their parts. So yeah, like Framlingham Castle, local landmark, it's been used for 800 years for all kinds of things. I'm not going to suggest that that's because it's made of pebbles, but it's all about making our software reusable and reconfigurable at the lowest cost possible. So service-oriented architecture and microservices are really just talking about bits of software working together. There's nothing more complicated or scary than that, really. So yeah, SOA is just bits of software working together. Microservices are just small bits of software working together. To be a bit more specific, talking about service, I'm talking about a piece of code that offers some functionality to the rest of the world. So it's self-contained, it just does one thing, and it has an API on it. That's all we really need. So something like an authentication service, receipt booking service, that kind of scale, it just does one thing. We don't want to make them too broad because we start getting towards that massive software problem again. And it's the kind of thing that you might say have a concierge who can do everything when you're staying at a fancy hotel. You wouldn't hire a concierge just because you needed to book a train ticket to London. Like, we just want something that does one job and does it really well. Microservices, in contrast to services, are just smaller. There's no magic to it. They're more focused, they're sort of in the vein of the Unix idea of small sharp tools. They're very small, they do one thing really well. Service orientation is just like when we talk about object orientation, we're talking about trying to make everything appear as an object. It's just a conceptual model that we apply to our software. Service orientation is exactly the same. We're just saying that everything in our code base, or everything that makes up the piece of software, is a service. So it has an API, it does all of its own thing, it does one part of it. So it's like saying about object orientation when we talk about the idea of high cohesion, low coupling for objects. You want the same from your services. You want them to do one thing really well. It felt wrong to not use the word architecture because that's the A in SOA. That's literally just how do we make these things talk to each other. So what do we use for our API? What do we use as our communication medium? These are all things that are up for grabs. Like, I think most people would suggest that like a JSON API over HTTP is pretty much standard and ubiquitous at this point. There are plenty of Oracle-shaped businesses like Oracle that will convince you that you need to buy Oracle Service Bus and do all this stuff. And there's a huge stigma around SOA from that sort of enterprise pushing of things and of crowbarring big products in that aren't necessarily needed or are needed. I'll talk a bit more about how to wire things up later. So first I've got a couple of little examples. One which Kerry might find vaguely familiar is, imagine a piece of software that starts off monitoring something, say, about a broadband service or a broadband network. So you might have some user account and user authentication to control who can comment on things and what people can see. And then you might want a bunch of things like how many subscribers are on a particular router or how much bandwidth or whatever. And the yellow bits are sort of common, bits of code that you might want to say, I've got an IP address, where is it? Or I've got a bunch of data, what's the average rate on it? Those kind of helper functions that float around in that software. This is the kind of thing that we've been building, where we start off building a tool that does one thing well, and it grows and it gets more things in it, and they're all in the same database schema, they're all sharing persistence, and it starts to get bigger and bigger, and we keep adding to it. The service-oriented approach is just to blow all that apart and to put things in separate projects, in separate processes. So all of these arrows are basically like just talking RESTful APIs, or just talking JSON at each other. And the idea is that we have multiple code bases that we just spin up multiple instances of, depending on our scaling, to do the work and to actually do the stuff. So for us at the moment, we're moving towards this kind of design where we're trying to keep the public API and the UI as one thing, but they're basically just marshalling all the services behind them and presenting them out to the world. This is actually more than just theory. This is how eBay and Netflix and somewhere else. This is where large companies are going. So obviously Netflix is massive. It's like 30% of broadband traffic. They have a front-end API where all their apps and everything speak to, and then they just have banks of services behind it. So for scaling things, you just suddenly say, oh no, we're depleting the foo service, we'll just spin up more of them. You have a load balancer, you chuck your new foos into the load balancer, and that's it, you have more capacity. So it makes that kind of thing really easy. I'm getting ahead of myself a little bit, because there are some downsides, but the pros are our projects stay small, they stay easy to test, they stay so that you can hold the whole domain in your head at once. So you only have to remember the bit that you're talking about right now and the interface that has to adhere to. You don't have to comprehend the whole system. So you can stop thinking about that kind of thing and trying to hold all of it in your head. And you can focus more down on these little pebbles. And there's something like a beautiful opal where you can just look at it and you can see all the bits of it. You can see all the coloured flecks and everything, and you can get a good appreciation for what that's made of very, very quickly. So that's a massive advantage, especially if you're working on a team where you've got to move around several products, or you've got new people coming in, or it just makes life a lot easier keeping things small. So some of the other pros are you get APIs everywhere, which is brilliant, because now you can hook into things, and that means that you've got a seam if you ever want to add functionality. You've got an API you can call. You don't have to do a massive refactoring to pull apart a load of objects that are all talking to each other. You've already got that place ready to bolt extra functionality into. The other one, which is one that I haven't really seen people take advantage of yet, is that because everything is made up of APIs, and that is a standard in and of itself, you can use multiple languages. So anything that can speak, RESTful JSON, suddenly you can use it. You can have a complete mix of everyone's favourite languages, or whichever language or framework is best for the job. Obviously at the risk of some complexity, at the downside of some complexity and whatnot, but good times. The other thing is that each of these services become replaceable. So instead of having this big ball of mud at the centre of your application that's going to take loads of time to refactor, you can just look at the service and say, well, the API is okay, but frankly, the way it actually works, I'm not keen of. You just write another one. As long as you write something that adheres to the same API, it's fine. So there's the idea of demolition-led development, or destruction-driven development, so DDD, where you just say, sod it, I'll just get rid of it and make a new one. it also means that you can have modular deployments. So you can start pushing out just updates to bits of functionality without risking the whole. If you're someone like Netflix or Facebook, where you've got a really massive app, that allows you to start doing canary deployments, where you pick, say, 3% of your services, and you just upgrade those 3, and you send 3% of your traffic to those, and you examine, are we seeing more exceptions out of those customers' traffic? You know, are we seeing them spend less time on site? It's kind of like A/B testing, but for your code. Like it gives you another tool that you don't normally have. Composition and reuse. So this is where I go on a little bit of a divergence, where I talk about how much I love composition. Because composition is fantastic. Like, this is the best thing that we should do with our code. So for example here, you might not be able to read that, but one of my favourite examples that I've already probably cited 2 or 3 times is the way that Unix has the idea of small sharp tools. So you have small command line apps that do one thing, but you can compose them really quickly. So like there, if for some reason I want to know some vague stats about the number of times I've run sudo commands, I can just pipe a bunch of these things together. So composition is the fluffy kitten of software. Like, this is what we should be trying to do. You know, it's small and it's lovely, and it means that we can reuse things. It means that we don't need to know the whole system at once, and that we can just swap components around. But composition is more than just one kitten, because it's about adding lots of things together. So it's more like if you have loads of kittens and they're all snuggling a dog, because you've got all these things that just work really nicely together. So yeah, that's my attempt to just embed the word composition and warm fuzzy feelings in your head. Like, that is the highest praise our code can get. So the last thing is Conway's law, which is I'm not going to explain it. I'm just going to put the quote up because I knew I'd forget. Conway's law basically says that any organisation builds software that reflects the hierarchy or the organisation of the people building it. So the best example, because that's all a bit bizarre, I can see people's eyes glazing over already, is that you might end up with a company where all the DBAs sit together in one team, and then all the middleware specialists are in one team, or the UI specialists are in one team. And that leads us to build sort of very rigid lines in our application, where expertise stays in those groups. And you don't end up with a particular amount of sort of mixing of ideas, and things tend to get crammed into the layer that the person who wanted them was at. So you end up with features sort of being misaligned, and you just end up with things looking a bit squiffy. By using microservices, we can actually group people together in much smaller teams that are just focused on delivering the whole stack. So we go away from this problem that big companies have, where you've got a nice small company and you've got a bunch of people who all talk to each other, and everyone has, you know, a bit of a specialism, and everyone knows a bit of everything. And then the company grows and grows, and you end up with people who are, that's the database specialist, and that's the UI specialist. And the knowledge starts to sort of separate out, and people start to know an awful lot, but only about one area, and you sort of lose that trading of ideas. By grouping people together around the services they're building, you can actually sort of get that enrichment of ideas going again, where people are talking to each other, and you can end up with much more integrated bits of code that have sort of higher cohesion, and people have more of an understanding about what they're building. Digression over. There are some downsides, and some fairly significant downsides. The most obvious one is probably the operational overhead. So you've gone from being able to just press deploy once and have your software out there in the world, to potentially having to deal with deploying lots of times and lots of little things. It also introduces new failure cases. So we've gone from my nice Rails app, where the database sits on the same server as the application server or whatever, to a world where suddenly I can ask for something and it can fail to come back. Like, maybe we have a network outage or something. I can't rely on services being up all the time. Ponder that for a moment. The other one is, as I've already alluded to, modular deployments can also be a real pain, because now you have to make all of your code, or you probably want to make all of your code able to deal with concurrent versions. So if you make a breaking change to the API of one service, you've suddenly got to deal with that in everyone that consumes that service. So it's not insurmountable, it's stuff that we can deal with, but it is extra cost and extra time that we have to put up with. And the last real downside is the monitoring tooling. So you end up with far more processes that you have to keep alive and far more things you want to keep an eye on. So you've gone from maybe 1 or 2 log files that you can just check to multiple log files all over the place. You start needing more tooling. This is something that actually, since the cloud happened to us all, that generally we're getting better at anyway. So you've got things like Splunk doing log aggregation for massive farms of logs. Tools are out there to do these things, but there is a cost while you get used to it, while you find the tools that you like. Ultimately, everything comes down to what's right for you. It's all about scale. I will say from my recent experience that we thought, it's a small app, we don't need all of this, and we're now trying to retrofit a lot of it and trying to break the app apart before it gets too big. So it's a bit of a gamble as to whether you just say, no, I will stop at some point and we will down tools for a month and we will rebuild or whatever. It's up to us as professionals to make a call and have people laugh at us when we make the wrong one. So enough about the pros and cons. There are a few things that, from what I've read and what I've looked at, that can make the whole thing a bit easier for you. So I've got like a few vague suggestions of stuff that you might want to try if you're going this route. So the first one is mainly the approach. You want to define some microservices, because it's service-oriented, and you want to make them talk to each other. So those are the 2 real question points we've got to deal with is, what are the services going to be, and what are they going to do, and how are they going to talk to each other, and what's it going to look like. On the defining them approach, this idea of cohesive services, so a service that deals with one thing very well, tends to be the guiding light. So you basically want to ask yourself the question when you're looking at your service or at your code base, does this project or does this sub-project, this service, do one thing? And if the answer is no, you probably want to refactor it and split out some functionality into another microservice and start again. This can be pretty time intensive. This is what we've been doing on our project recently. It requires an awful lot of things because it's like when you get everything out of the cupboard to sort it out and then suddenly all the bits don't go back in the cupboard and you have a million things that you have to rebuild. It's really easy for this to spiral out of control. The best thing to do is to pick one area and refactor it and have one microservice that does that. So for example, I mentioned earlier the location service for finding out where something is. Today, somebody just refactored that in one day. It's a separate service, it has an API that we call on it. It's another few hours to refactor the actual code base to call that, and then we're done. Like we have a web service. It's far better to go about it that way rather than just trashing everything and basically starting over. So, yeah, basically web services, keep them small, keep them focused. In terms of actually making them talk to each other, we have 2 real options. The first one is direct communication. So we have 6 services, we literally just say, I will tell you where all of the other ones are, and they talk directly at each other. That's great for small numbers of components, because you've got no overhead. As soon as you've got 2 services, you can make them talk to each other. There's nothing else to worry about or set up. It's also very good if you're breaking up a large system. Excuse me, like I said, if you're refactoring, you can just keep grabbing a bit out and calling it, and then grabbing another bit out and calling it. It's not so good because the systems have to know something about their collaborators. So you're sort of lowering cohesion because suddenly knowledge about the other systems is sort of leaking a little bit. You have to give them, load balance pools or a URL to talk to. It's not the end of the world. That's got to happen at some level. And yeah, I have no idea what that note is. Cool. The other option is to go with a event message bus in the middle of things. So this is great because frankly it's easier to visualize. Like if you've got millions and millions of services and you just tell them all talk to the bus, that's great. Like you don't have to worry about what's wired to what anymore. Because it's all talking to the bus, it all works the same way. It's also better or it tends to lend itself more to event-based things where you don't exactly know what you're going to be building next, and you just want to say, I'm service A, and I've just done blah, and you don't care whether anybody else actually cares about it, you just announce it to the service bus. At any point then, somebody can just say, oh actually I care when blah's happened, and they can register another service that just listens for those events and does something when that happens. It's a bit swings and roundabouts because obviously you end up with a lot more messages on your bus than you strictly need, but it does make things far more extensible. It's sort of more of that open-closed idea from where we're getting. being applied where things are open for extension, so it's easy to extend them, but they're closed to modification, so you don't have to go and edit them or change the current services to really get it going. The downside is that you need a message bus. So that's a single point of failure. Frankly, most of the messaging buses that are out there now are pretty resilient. I mean, obviously nothing's 100%, but there are plenty of mature message bus technologies out there now. And the other thing is that the message bus can hide what depends on what. So I've gone on about like being able to understand things at a glance. You still have to understand the entire system at some level. And if you're a new developer to a project, if you've used direct messaging, you can look in the source code and say, oh well, here it calls this and there it calls that, so I know it depends on those two services. With the bus, you've got a bit more of digging through to find the topic or the specific messages and the pattern of the messages it subscribes to. Again, it's not insurmountable, but it is a bit more costly than the other way. Frankly, between the two options, in general, I think most people want to go for direct. It seems to be a better way of getting started with things. I'm sure there are plenty of people who would completely disagree. It is entirely up to you what you think, but I found that direct has given me a nicer sandpit to play in while I learn how to do this, or while I'm still learning how to do all this. So now we've talked about how to make them small and how to get them to talk to each other. We've got the question of what to say to each other. So frankly, everything seems to be a pretty good answer. So like I say, it makes that extensibility, it makes things more extensible because you just say everything that happens to your service. At any point somebody else can care about it. You're allowing people hooks all over the place where they can come and just snag more code on and they can extend the system. It has got increased noise, so if you're doing a lot of logging or if you're trying to look at every message being passed through your system, you will see a lot of extra messages that aren't actually consumed. But frankly, if you get a decent log monitoring tool or you turn your logging down, that problem goes away. The point is that kind of noise is very cheap to a computer. It's expensive to a human looking at it and reading logs or wiresharking it or whatever, but the machine doesn't care particularly. The other thing is that whilst we're being quite chatty, it helps to cache things. Like you can sensibly put caching between services at certain points where that content isn't going to change frequently, and that can help offload some of the chattiness. The other thing is that you're going to hopefully be making a lot of services, so you should make it easy. You should invest the time in coming up with a set of tools that you like and a set of patterns and processes that you like. So we recently took a good few days, I think most of a week, just coming up with a gem set and trying a bunch of things in the Ruby project to really work out what we liked. And we've now rolled out, or started on our second service following the same thing. It seems to pay that if you are using the same ecosystem, that you do work that stuff out. And keep refining it. You know, keep getting to the point where you can make two copies that look absolutely identical, and you can just keep churning these services out. Yeah, it's kind of the idea of find what you love and let it kill you. Like, spend the time up front to come up with something that's really going to work for you, and then play with it. So yeah, in summary, cool. Big projects become unwieldy. Keep things small. Focus on making reusable components that are going to be able to be composed together and be able to be rejigged in the future. Use APIs everywhere to cooperate between things, and make lots of chatty small things. Basically, pretend that you're making Lego. Like, just make all these things that have extension points all over them, and you can just snap them together, and you go, actually I want that over there, and you can just make whatever you want. So yeah, a bit of further reading. Martin Fowler's post on microservices is fantastic, and goes into a lot of depth about the advantages. That's where I nicked all the Conway's Law stuff from. He's really thought that stuff through. And there's this brilliant talk by Fred George from Barcelona RubyConf a couple of years ago, where he shares a lot of anecdotes about projects where they've done this kind of thing and it's failed, or they've done it and it's gone really well. There's a real wealth of experience in that talk. It's quite an enjoyable talk. A few photo credits. Thank you to everyone who puts photos online as Creative Commons so that we can hoover them up and use them in our things. And yeah, thank you. I'm Adam Whittingham. Any questions?
In terms of making decisions about what gets said to what, do you have a sort of Do you have an overall architect that goes, you don't want to, that's too wordy, you don't want to say too much of that, or do you let it go down to the people who actually, do they kind of discuss what's needed from each side? So say you've got service A, I've got service B, and I need some information from you. Do you go via a sort of higher power, or is it literally just back and forth?
Yeah, we don't, because we're a team of 6 or 7 people, and we own all the services that we make, so we haven't really got any need for mediation. You just throw a tennis ball at the person who last worked on it, and ask them. I can imagine in larger situations you might want to start to have somebody with an eye on the overall picture, but the aim really is like that Lego idea where you can just snap things together and you've just got extension points and it's just easy. Obviously that doesn't work when somebody wants to add functionality or change an API, and that is really the Achilles heel of this whole thing, is that you've got to deal with versioning quite carefully. So I think it was Fred George's talk that I mentioned. He goes into some depth about a set of rules that they came up with about how often you could deploy and what a deployment entailed, so how many breaking changes you could make, which was essentially 0. And they came up with a versioning structure that they were quite happy with, and a way to sort of gracefully migrate services from one to the other. That is the real snag with all of this, is like you have to get really good at that. You have to understand versioning, and you have to get better at being able to deploy something and not break everything and have to redeploy all the dependencies in one go. So, to be honest, it's an interesting problem to solve, and it solves all of your scalability. It solves many of your scalability issues, because you just have a load balance and you just spin more of these things up if you haven't got too many worries about persistence and all the fun that comes with that stuff. So, yes. Yeah, we just talk to each other. We don't really have an overall architecture yet.
I think in practice, whenever I've had to deal with other systems, if you get to talk directly to the people doing it, it always goes much more smoothly than if you try and talk to some architect.
The only thing
better word.
I'm not sure if that's because our architects or
common.
yeah.
The only thing I've found is that if I'm writing my code, is if I'm thinking about writing an API, I keep refining and changing the API before I finish it. So I actually it takes me a lot longer to get to the point where I deliver something which I feel I'm giving the right information across. I guess that's just a thing.
The only mitigation to that, I think, is that if you keep things small enough, the API is pretty obvious. So I had, I can use my noddy example, Kerry, that I threw together. I had a really tiny example using Sinatra. Of a couple of services talking to each other. So I had a time service, which literally just gives you the time somewhere, and you can optionally give it a time zone. So it's that idea of a small sharp tool. It only gives you the time. It's not a fantastic blob of functionality, but it's got some configuration to it. And then along with that, I built this beautiful thing which looks great on 8 pixels. Which just tries to get the time API that I just showed you and works out what you should drink based on what hour it is. So yeah, when I left work it was set to water, now it's beer. So yeah, not a great example, but it's that kind of level that you're looking at, is like something really small where the API hasn't got too many bells and whistles. It just does one thing. Not always possible. It depends what you're building. And yeah, that's where that is the snagging point, is like versioning and dealing with rolling out multiple versions and gracefully dealing with things not having the version that you wished of them.
Okay.
So that sort of leads on to my questions. I mean, this is probably a good example of it. If you were making that call to time.now locally, you're now splitting it out to be a call over the wire. It's probably at least an order of magnitude slower. Presumably there comes a point where you don't want to make it any slower, because suddenly the whole thing grinds to a halt because you're making web requests left, right, and centre.
Obviously there's a point going the other way where you literally have one line of code with 6 lines of marshalling and API stuff around it, and that's going a bit too far. But that is an oddie example, just to try and prove your point. But yeah, there is like a lower limit. I don't really know where that is.
So I've used, I think, the message bus style system of microservices. And the big killer thing that I never really sought the answer to was when you've got when you're doing updates on different systems at the same time, and one of them fails, you've got to roll back all the others. How do you manage transactions across sort of multiple services?
That I honestly don't have a good answer for. I'm not sure there is one. The Fred George, I hope it's Fred George, I keep mentioning Fred George. His talk, let me just do it. Yeah, it's Fred George. His talk, those rules I talked about, one of them is that you can't make, it's something about not being able to make a break and change to everything else. So you have to be able to deploy your service in isolation, basically. So it's more either versioning or like feature switching and just saying, well, if you ask for version 3, you get these extra bells and whistles. So you deploy one set of services and make sure that they're okay, and then you deploy the dependencies, or the new version of the dependency doing version 3. But then your rollback is whatever the last thing you deployed which broke, you take that back out of the loop, and everything falls back to using the old versions. So you
Okay, so that's, yeah, so I meant more sort of like,
Transaction rollback.
yeah, so if you were doing an update on your, I can't remember the diagram here, but they had like users and something else. Say you've got users and bank accounts, I guess, if they're kept on separate systems for some contrived reason.
Sorry, I just realised about 3 times I pointed to slides that weren't there. There we go.
Yeah, so if you're doing an update to this system and that system,
Yeah.
and how do you, the one of them fails, they both got to fail. How do you keep it atomic?
The best way I know of doing that is to avoid it entirely by trying to make sure that anything dealing with one concept, one domain model, is encapsulated in one system that maybe has a few APIs on it. And then, yeah, you just roll that one back. I'm lucky enough to have not come into any particularly hard problems just yet with having to deploy multiple components at once and roll them back together. We've been playing a little bit with Capistrano to that end, so that we can actually roll things, we can have a master rollback that will take a bunch of things down. But it seems to be worth trying wherever possible to keep these things encapsulated about one domain object. And then if you've got the versioning of your API down, then like I say, you just, the first one, like A goes out, that's fine because everything is still talking the original version to A. It just has extra bells and whistles waiting. And then if B fails, calling the new version of the API, you just roll B back and everything else is happy. Actually rolling back like a transaction in flight or multiple services that all talk to the same persistence or to the same model. I think the general rule is that you try to avoid having services talking to the same models. Frankly, I don't know a good answer to dealing with it, other than going through the hard labour of coming up with a rollback scheme and coming up with some way of pulling the plug if it goes wrong.
For the versioning thing, sorry, just reminded me of something. The trick I've seen with that is that you make the APIs really RESTful, so they're self-describing, so that if you make a change, the JSON that you sent back describes the new thing, so you're not, I'll talk to you about it afterwards.
Yeah, that'd be good because that's something we're still playing with. I'm a really big fan of, we've had, was it underscore meta we've been using in a couple of places, blocks. We haven't really gone to town on doing more than just handing back the data asked for, but we've played in a couple of projects with having like an underscore meta object in the JSON that comes back that has other URLs of other services or other commands related to the object, so you sort of get back some level of API with it. That doesn't sit so well with microservices because you're coupling yourself to knowledge of the other services and the other APIs, and suddenly you've got a
Is that really
dependency.
true? Surely all that's happening all you're doing is documenting it that way, making it actually RESTful. The dependency would still be there.
But
You
it's
just
more
have to
if
code
you upgrade something, if you upgrade the version of one of the dependencies, you've got to make sure that. Actually, no, you don't, do you?
Because
You just carry on
still
using the version of
change.
the
What would
API.
happen is you wouldn't know until you got an
Yeah.
exception.
So yeah, that
You
would
should
fine.
just be able to follow things.
This is literally the stuff that we're doing at the moment at work. So
Oh yeah, I'll have a chat with you afterwards. Hit some of these pain points, I think.
yeah, we've been quite lucky that we can chunk everything up by domain concept at the moment. The tricky bit is that these blocks are quite big and probably need to be broken down further, and we haven't really thought, or at least I haven't really thought or looked at how we're going to do that yet, how we're going to break those down. We're still working on actually just blowing up the whole big app.
And the other big advantage we've got is mostly kind of event-driven stuff coming from a back end. So it's like something goes and polls something and updates some data. There's not users doing stuff to it. So it's all stuff coming out of the network that we're monitoring. So it's much easier. You don't have all those conflicts because you don't have multiple people changing things at once.
Our only real write operations are people commenting on things at the moment, which is lovely for this because you stick all the comments in the table that just has like an ID or something. We have like rather polymorphic comments. You just go la la la, everything's fine. So some of the more really tricky edge cases, like I just